Hello, ladies and gentlemen, and welcome back to another fantastic lesson on distant learning. And we are starting a new unit today. We're starting what's called the sine function, not the sine ratio and not the sine law, but we're going to start talking about the sine function. This is actually 5.1 for your textbook. So we're into chapter 5. And it's periodic functions that we're going to talk about right now. So not just the sine function, but a whole family of functions called the periodic functions. By definition, a periodic function is a function that repeats a pattern or a cycle at regular intervals, okay? So a periodic function, that's something that you're going to have to learn. A periodic function is a function that repeats a pattern or a cycle at regular intervals. So we're going to have the anatomy of the function. We're going to have certain characteristics of the function. One of them is called a period. The other one's called an amplitude. And we're going to have to learn what they are. So a period is the horizontal distance from the beginning of one cycle to the end of one cycle. So a period is a measure of a horizontal distance. Amplitude is half the difference between the maximum value and the minimum value. Now that we forget sometimes, but it's got to be half the difference between a max and a min. So amplitude is between a max and a min divided by 2, and the period is going to be the difference between the beginning of a cycle and the end of a cycle, a horizontal distance. So the amplitude is going to be a vertical distance. The period is going to be a horizontal distance. I'm not sure why I didn't put that in there, but this is a vertical distance. All right, and this is definitely a horizontal distance. So let's take a look at this interesting function I have here. Now, what we have here is a traditional XY coordinate plane here. You have two axes. You have what we call the horizontal axis. Often we refer to it as the x-axis. We have what we call the y-axis often, but it is what we call the horizontal axis. We make up a ordered pair that gets plotted on this grid, x comma y. And what we have here is a bunch of those points being plotted to the point where we've been able to connect them with a nice smooth line. So what's happening here is this pattern that I'm drawing here. So that lovely pattern is a whole bunch of these. It's a whole bunch of points that have been put together, and this is considered the function. We would give this function a name. Often we call it f of x. Okay, so this function. And what we're trying to show here is that this function would continue, most likely, in both directions. We're not assuming that it stops. So we might put arrows on the end indicating that this function continues to propagate in both directions. Okay, so if we take a close look at this function, we're going to see that it's made up of parts that could be reproduced. So if I was to take this function and to start thinking about it from maybe just that much, and if I was to take some scissors and to cut that piece out, you'd notice that I could take that piece and I could cut it out and I could put it right down here and it would match up perfectly. And I could pick it up again and I could put it down here and it would match up perfectly. I could pick it up and I could put it this way and it would match up perfectly. So this is what we would call the cycle, okay, or a pattern. Here's a pattern. So this distance from the start of the pattern, I'm going to call that the start of my particular pattern. I'm going to call that the end of this particular pattern. This horizontal distance is going to become what we call the period. And that would go from 0 all the way up to, let's see, we're going up by 2s, it look like 2, 4, 6, 8, 10. So the horizontal distance looks like 10 here. The vertical, the amplitude, we have a maximum of 4, we have a minimum of -4. That is a total distance of 8, so half of that would be 4. So I'm looking at an amplitude of 4 and a period of 10. Now, that is not the cycle that this particular example wanted us to look at. The cycle that this particular example wanted us to look at, if I can find another highlighter that's a different color, and I did, they actually wanted us to start looking at this pattern from here. Now take a look at that pattern. So pointy, down, curve, pointy, pointy, pointy. If I was to cut it here and cut it here, that would be a pattern that I could place here and it would match up perfectly. I could pick it up and place it here and it would match up perfectly. There's no difference. Now it looks very different. Those two little shapes are very, very different, but let's look at its characteristics of period and amplitude. In terms of its period, it would start here now. This would be its new start. And it would end here now. This would be its new end. So its new start, instead of starting at 0, we're starting at, let's say, 2, 4, we're starting at 6. And we're ending at 2, 4, 6, 8, 10, 12, 14, 16. We're ending at 16. The horizontal distance between 6 and 16 is, again, 10, and that's what we had before. And if we look at the maximum value, which is 4, the minimum value, which is -4, it still has an amplitude of 4. So what I've demonstrated here is periodic functions. You can actually choose the pattern wherever you want along the function as it is. And some people will choose it. So that was my pattern that I chose at the beginning. And here's the pattern that the example chose. And there's other patterns that we could have started from. We could have started from this pattern here, gone up, down, up, and back down. And notice, if we had taken that pattern, let me show it to you. So all the way up here, all the way down, all the way back up, all the way down. So that weird looking M, if I had cut that M out and placed it back at this end point, pick that M up and put it down here, it would have matched up perfectly. And picked it up and put it up there, it would have matched up perfectly. You can see the other M right here. And again, if we look at its period, so it's going from, let's see, 2, 4, 6, 8, 10, 12. So this would be approximately, oh, it's just a little over, I can't read it perfectly, but you would notice that this distance and this distance would be 10. And you'll notice that this high is 4 and this low is -4, and that would be an amplitude of 8 divided by 2, which is 4. Now, notice that if I choose my pattern at some places, it might be really, really difficult for me to be able to determine what the x value is, right? But if I pick it somewhere that's easier, like 0, and go all the way up to 10, it was a lot easier to do. Also, picking at 6 and going up to 16, I just had to do 16, subtract 6, and get that distance in between. Okay, so that's your example to begin with, and I'm going to stop the video here, and then we'll do examples 1 and 2. Okay.